Alright, welcome back. Well, in the previous video we covered the properties of logs and exponential, okay? Exponential and logs. Basically these three properties right here, very important. And you see in all the three properties you have a log and you have an exponential, okay? Now, what I want to do right now is cover property characteristic of logs and characteristic of exponential. So first of all, where do they come from? Let me quickly remind you of some fundamental properties of exponential that you've known for a long time, okay? Properties of exponential, not of logs here, just exponential, okay? The two basic one are that if you multiply two exponential and they have the same base, then what happens here is that you add the exponent. You keep the base, don't multiply the base. This is not a squared, okay? You keep the base and you add the exponent. And the second one, there are others, okay? I'm just going to write these two because the property I'm interested for logs come from these two. And the second one is if you take an exponential and you raise it to another exponent, then in this case, this is the same as taking an exponential base a and raise it to the product of exponent, okay? Well, listen, because logs come from exponentials, okay, you know they're inverse of exponential, then something is going to happen to these properties, okay, in the switch right here, in the switch between exponential and log, something is going to happen to this property, and I will have some properties of logs. Properties of logs. So let's cover what happens to these two, and then I'm going to give you two more which are very common, derived from the first two right here. So what happens to the first one right here? Yeah, the first one. Well, I'm not going to prove it, okay? It's not difficult, but I'm not going to prove it. The first one would translate into, if you take the log of a product right here, then that would become the log, that becomes the log of the sum of logs, sorry. Log of a product is the sum of logs, okay? Log base a of y, all right? And the second property would tell you that if you were to take the log of an exponential, now you see right here, my base is not the same as a right here, okay? This is base a and this is base x. If they were the same, then I'd be right here, okay? See right here, when you have the same base, then you just cancel everything and this is just x because these two functions are inverse of each other. Let me reset, okay? But this is not the case. I'm taking the log base a of an exponential base x. So here it does not gonna cancel. But what you can do right here, you can bring the exponent outside and it's simply gonna multiply the log. It's kind of interesting because it transforms an exponential into something that is linear, right? It's y times something. This is linear in y. This y right here is an exponent. Right here, y just multiplies something. It's a linear expression in y. All right. So here, I promise you two more. I know you're very anxious to learn them. Number 3. So look at this one right here. Look at number 2. And look at number 2 if you take y equals -1. Okay, so here, look. I'm just green. This is, I'm going to show you how it works, okay? So log base a of 1 over x. Now, 1 over x. How can you rewrite that with an exponential? Well, this is the same as log base a of x to the -1, right? And now you can apply this property. So this is -1 times log base a of x. And you know when you multiply something by -1 is the same as taking the opposite of that thing, okay? -1 times something is just the opposite of that thing. So this is the opposite of log base a of x, okay? And this is what I want you to remember. Property number 3 simply says, a very useful one actually. Yeah, it doesn't matter. Actually, here, let me write the right side first. Right side. Negative log base a of x is log base a of 1 over x. I use it very, very, very often. For example, if in one of my expression I land on something like that, like, stop it. Opposite of ln of, I don't know, 4/5 right here. okay? The opposite of ln of 4/5, this is the same as the ln of 5/4. Why do I use it all the time? Because I never need to write a negative sign in front of a log. Just flip what you have inside. And I'd rather read something without a negative sign than with a negative sign, okay? This is easier to understand this than if you have a negative sign. Okay, and the last one we covered that in class. I don't think I mentioned number 3 in class before the break. The last one, well, it's a mixture of, this is come on, no, stay, here we go. It's a negative sign. Last one is a mixture between 1 and 3. And it says that the log now of a ratio, okay, this is the same as the difference of log. Okay, the log of a product is the sum of log, while the log of a ratio is a difference of log, okay, of logs. All right, I'm not going to rewrite this property using ln or using log. I'll let you do that. Don't know if I did it in class or not. Okay, so these are properties of logs, very, very common. Now, one more set, I think. Yeah, one more set of formula that I want to give you. And these will be called the change of base formula. Change of base formula. Okay, they're not difficult. They're pretty simple. Very useful. Very, very useful. Change of base formula. All right, so the first one, we covered it in class. You can show that here a log base b of x, okay, this is a base b right here. You can change this writing into any other base. This is log base a of x divided by log base a of b. And you see on the left side you have a base b only, okay, base b. While on the right side, I don't have any base b, it's all returning base a. I have changed my base. I have changed my base. Now, of course, the log we use in math are the log that you have on your calculator. For a, we would choose either a equals 10 or a equals e, right? So log base b of x. If you choose e, it would be ln x divided by ln b. And if you choose 10, it would be log x divided by log 10. It doesn't matter which one you choose, by log b, sorry, because the ratio would be the same as this one. Here's another property. This is for a change of base for logs. Let me give you the change of base for exponent. We have not covered that in class, but here, let me show you how simple it is to show it. All right, let's take an exponential base a. Okay, this is an exponential base a. Actually, right, actually, let me go directly with the most common way of doing that. I'm gonna write that with an exponential base e. So how do we write that in base e? Okay, question. Well, it's very simple. Look, you take a to the x, and you know that this is the same as e to the ln, right? E to the ln will cancel each other, right? Because this is this property, right? Right here, you see? E to the ln cancel each other, and this is just equal to x, right? So let's see what I'm going to do right there. Except that x this time is a to the x. E to the ln of a to the x, right? Right? And this is just, now use the rule for the power right here. You take the x and you put it right in front. So it's e x times ln a. Okay? And that's it. Why? That's it. What is this right here? It's an exponential base a, right? This is a base a exponential. What do you have on the right side? You have a base e exponential. You switched bases. That's it. That's all. So here's the formula. A to the x is equal to e. Let me switch the ln a and x right here. E to the power of ln a times x. That's it. Okay. All right. This really concludes what I wanted to remind you of. Recall in terms of exponential and log. This is not really a recall. I'll mention it in class, but I hope you're going to watch this video. The rest is all a recall, okay? Okay, all right. Let's